Okay, strap in everyone because we are diving deep today. And I mean deep.
Yeah, definitely deep.
We've got some listener research that, well, it really challenges some pretty basic assumptions about how the universe works. Photons acting all sorts of funky, a model of the universe that's basically a movie reel, and some notes. Well, let's just say there are some disagreements.
It's a fascinating
Uh,
set of ideas for sure. It seems like they all sort of circle around, that fundamental question, what is time? Like, really,
right.
could our understanding of time, be totally wrong?
Absolutely. Let's kick things off with this physics paper. Experimental evidence that a photon can spend a negative amount of time in an atom cloud. So these researchers, they measured how long atoms stay excited after, getting hit by a photon. Sounds pretty straightforward, right?
Yeah, at first glance, sure.
Yeah.
But here's where things get really strange. They found that sometimes the atom was excited before the photon even hit it.
Hold on, hold on. Are we talking about time travel here? Are we breaking the laws of physics?
Not really. Think of it this way. If you shine like a flashlight through a glass of water, the light bends.
Right?
That's because light travels at different speeds through different materials.
Uh-huh.
This idea of group delay, it describes how a pulse of light can seem to speed up or slow down, depending on what it's moving through.
So, okay, the photon isn't actually going back in time,
Right.
but it's messing with the atom in a way that makes it seem like time is like going backward.
Yeah, exactly. And the paper, it actually suggests this isn't just some weird math thing. This negative group delay, it actually has real measurable effects.
Wow.
It could even change how we build new technologies like optical computers.
So our whole idea of time moving in one direction, that might not be the whole picture.
It might not be. And that's where this theoretical framework comes in. It's a paper called Integration and Refinement of Digital Physics.
Okay.
And it basically says that space-time, it isn't this smooth, continuous thing. Instead, it's like a series of frames, like a film reel.
Okay.
And each frame is made up of tiny units that they call pixels.
Pixels, like on a computer screen?
Well, it's an analogy,
Okay.
but it helps to visualize it.
Yeah.
Each pixel is this tiny bit of space-time, and each one has a meta tag attached to it.
A meta tag? What, like metadata for a photo, but for like a piece of reality?
Exactly. Those meta tags would hold information about that specific spot in space-time, its energy, its momentum, even its quantum state.
Whoa. Okay, I'm starting to see how this connects, but how do those backward in time photons fit into this frame by frame universe thing?
Well, according to these overview notes you sent, some researchers think the negative time results actually support this idea of a frame-based universe.
Okay.
It's like the photon is like jumping ahead to the next frame of reality instead of smoothly moving through time.
Okay, so instead of a smooth flow, time might be more like a series of snapshots.
Yeah.
And these photons, they're like skipping ahead in the slideshow.
Exactly. And remember those meta tags we talked about?
Yeah.
One researcher, Fedotov, he brings up this idea of hidden resonance. He thinks each frame, that it could have these resonance tags that affect how particles behave.
Hidden rules. Are we talking like some kind of secret code inside each frame?
Well, that's a point of debate. Yeah, some researchers, they think it's just part of the model. But others, like Fedotov, they believe it points to like a deeper level of reality that we haven't even begun to understand.
So it's like those choose your own adventure books, but instead of us making the choices, it's these resonance tags deciding how the story goes.
It's a thought-provoking analogy, but it does raise a big question. If everything's, set by these tags, does that leave any room for a free will?
Whoa.
We'll need to unpack that a bit later.
Yeah, definitely. But first, how do we even test any of this? This seems so theoretical.
That's where our third researcher, Zac, comes in. He's trying to build a simulator to bring all of this to life.
A simulator, like a video game version of the universe.
Well, a very sophisticated one, yeah.
Okay.
Zac is trying to model the universe as a series of frames with
Okay.
those pixels and meta tags.
Uh-huh.
He's even including those resonance tags to see how they might affect the simulation.
Okay.
He's tackling things like quantum entanglement, particle tunneling, even the Big Bounce.
Wait, he's trying to recreate the entire history of the universe in a computer? That seems incredibly ambitious.
It is, but that's what makes this so exciting.
Yeah.
If Zac can pull this off, this simulator, it could actually provide evidence to support or maybe even refute, this whole frame-by-frame model.
Incredible. We've gone from photons acting weird to questioning the very nature of time, and now we're talking about simulating, like, the whole universe to
Yeah.
see how it all fits together.
That's the beauty of this deep dive.
It is.
We're piecing together these seemingly separate ideas to see if they paint a coherent picture of reality.
And that picture might be a lot weirder and more wonderful than we ever thought possible. But before we get too ahead of ourselves, what does all this actually mean for us, here and now? If the universe really is frame-based, does that, like, change how we should live our lives?
That's the big question.
Yeah.
And that's what we're going to explore in the next part of our deep dive.
Yeah, welcome back. Before we, jump too far ahead with the implications of all of this, let's go back to Zach's simulator project for a second. Remember, he's trying to model the whole universe as a series of frames with those resonance tags.
Yeah, it's mind-blowing, really, trying to recreate the whole universe like in a computer.
Yeah.
What are some of the biggest challenges he's facing trying to build this thing?
One of the biggest hurdles is scale, right? I mean, we're talking about stuff that ranges from, like, the subatomic to the galactic.
Right.
Imagine trying to, like, simulate the Earth from a tiny grain of sand to, continents moving. It's a huge task. So how do you even start with that? Is it even possible with the technology we have now?
Zach seems to be relying on a mix of like advanced techniques and some serious computing power.
Okay.
For those tiny scale like quantum interactions, he can use established physics. But for the bigger stuff like galaxies forming, he has to, make approximations.
Right.
Focus on the really important part.
That's like creating a map. You can't include every single detail. You have to focus on the big important things.
Exactly. And for Zach, that means focusing on how those resonance tags might, influence how the universe changes. He's basically like running experiments inside the simulation, tweaking those tags to see how they affect the big picture.
Okay, so it's a virtual lab. He can test out these wild ideas about how the universe works. But even if he builds like a super realistic simulation, does that really tell us anything about reality itself?
That's a great question, and it gets at the core of what we're, exploring here. Think about it like this. Movies, they're made of single frames. But when you play those frames back fast, we see it as continuous motion.
Mm-hmm.
What if our experience of time is similar? What if we're just like perceiving these separate frames as a smooth flow?
So are you saying our brains might be like filling in the gaps, creating the illusion of time moving smoothly?
It's possible.
Yeah.
It's one of those rabbit holes this whole frame-based model opens up.
Yeah.
If our reality really is like a giant cosmic movie, what does that mean for how we understand free will?
Right.
If each frame is already set, is our sense of choice just an illusion?
Wow. That's a heavy thought. Are we just like along for the ride in this pre-scripted universe?
It's a question that's, puzzled philosophers forever. But those resonance tags, they add another layer of complexity here.
Okay.
Remember, they're supposed to, like, influence how particles behave within each frame.
Yeah.
Maybe they introduce some randomness, some unpredictability.
So maybe it's not like totally set in stone. Maybe there's a mix of pre-programmed rules and things that just emerge. And that creates space for like free will to happen.
It's a fascinating thought, and it's something that Zach's simulator might be able to, help us understand. By modeling those different types of resonance tags, he could explore how they change the behavior of particles, maybe even leading to like complex systems, like life itself.
So even if the universe works frame by frame, it doesn't mean we're just puppets on a string.
Right.
There's still room for something like free will to come out of this complex system.
Exactly. And it also makes you think about cause and effect.
Oh.
If time really is like broken up, does that change how we think about causality? Does one frame like cause the next one? Or is there something more complicated going on?
It's like those domino chain reactions. You see one domino hit the next, but what about the first push?
Right.
Is there something outside the frames that's driving the whole system?
Now you're getting into some really deep stuff.
Yeah.
And these are the kinds of questions that this frame-based model, it makes us confront. It's a whole new way of thinking that could like revolutionize how we see the universe and our place in it.
This whole conversation has been like incredibly thought-provoking, but I'm curious to hear more about the debate between the researchers. You mentioned some tension about those resonance tags. What's the disagreement about?
It comes down to a fundamental difference in how they interpret it all. Fedotov, the researcher who, came up with hidden resonance, he sees those tags as proof of like a deeper level of reality, something beyond the simple data, in each frame. He thinks they might even represent like a hidden time, a hidden dimension that we can't directly see.
So it's like he's suggesting there's this secret code like woven into the universe controlling everything.
Exactly. But Jesse, another researcher involved, he's more practical.
Yeah.
He sees the resonance tags as a set of like rules, like lines of code in a program that just tell particles how to interact and change within this frame-based system.
So for Jesse, it's more about how the system works, the mechanics of it. And Fedotov, he's looking for like deeper meaning, like hidden connections, maybe even a cosmic consciousness.
That's a good way to put it. And this difference, it highlights something really important about science: the need for both rigorous analysis and creative thinking. We need people like Jesse to figure out how things work, and people like Fedotov to ask those big why questions.
It's fascinating how their like backgrounds and personal philosophies shape how they approach the research.
Absolutely. And it's through those, passionate debates, those disagreements, that we really refine our ideas, test our assumptions.
Yeah.
And ultimately, we come to a deeper understanding of the universe and our place in it.
This has been an incredible discussion so far, but we've only just scratched the surface of Zac's simulator and what it could reveal about this frame-based universe.
You're right, we have. In the final part of our deep dive, we'll, really dig into the technical details of Zac's simulation. We'll talk about the challenges he faces building this virtual universe.
Yeah.
And we'll discuss what his findings might mean for us.
Stay tuned, because things are about to get even more mind-bending. All right, welcome back to our deep dive into this crazy idea of a frame-based universe. We've talked theory, we've gone deep on the philosophy of it all, but now let's get into the nitty-gritty of Zac's simulator.
Yeah, it's one thing to, throw out a theory, but building a model to actually test it, that's a whole other level.
Right. Zac's trying to do just that. And it's a massive undertaking, trying to recreate like the entire history of the universe, from the Big Bang to galaxies, stars, planets, maybe even life, all in a computer program. I mean, where do you even begin?
Well, he starts by, breaking it down.
Yeah.
Smaller, more manageable pieces. He's using something called discrete modeling. It's basically representing the universe as this huge 3D grid of those tiny space-time pixels we talked about. Each one has its own meta tag describing its properties.
So it's like building a Lego model of the universe, but digital. How do you make those digital bricks interact, follow the laws of physics?
That's where the frame transition operator comes in.
Okay.
It's basically a set of rules written out in math that control how the universe changes from one frame to the next. Think of it as like a cosmic rule book.
Okay.
It tells those pixels how to rearrange, how gravity pulls on them, how particles interact.
So it's dynamic. Each frame builds on the one before it based on those rules.
Yeah.
But how does Zac deal with the sheer complexity of everything? I mean, from tiny particles to giant clusters of galaxies all interacting with each other.
It's a huge challenge, and Zac's using a bunch of different strategies to tackle.
Yeah.
For the small stuff, like particle collisions or quantum interactions, he can use like well-established theories. Quantum mechanics, the standard model.
Yeah, those we have a pretty good handle on. But what about like the really big stuff? Galaxies forming, the universe expanding.
That's where things get a lot more tricky. For those large-scale processes, Zac has to use more, proximate models and simulations. It's a balancing act. He can't simulate like every single particle in the universe. It's just not possible. So he has to prioritize, focus on the most important parts.
So it's kind of like making a detailed map. You can't include every single building or streetlight. You have to pick the right level of detail to show the important features.
Exactly. And for Zac, that means really focusing on how those resonance tags might influence how the universe evolves over time. He's running simulations, changing the settings for those tags, and seeing how they impact things like star formation, galaxy formation, even the overall structure of the universe.
It's like a virtual lab where he can test these ideas about how those hidden rules might have shaped the universe we see around us.
Exactly. And the results of these simulations, they could be revolutionary.
Oh.
If Zac's model can accurately recreate what we see in the universe, it would be like huge support for this whole flame-based idea.
Like, it would be like watching a time lapse of the universe unfolding. But instead of capturing it with telescopes, we're We're seeing it emerge from like a set of basic rules and starting conditions all in a computer program.
Exactly. And by changing those starting conditions, those properties of the resonance tags, Zach can explore like a whole range of different universes. Maybe even discover new physical laws or phenomena that we haven't even thought of yet.
It's like exploring like a cosmic landscape, seeing what's possible within this framework. But beyond the science, this frame-based model really makes you think about some pretty deep philosophical stuff.
Yeah, it does. It challenges our basic ideas about time, about cause and effect, even free will. If the universe is really working frame by frame, does that mean our experience of time as this smooth flow is just an illusion?
Right, like our brains are tricking us.
It's a lot to wrap your head around. If reality is just a bunch of snapshots,
Yeah.
does that mean the future is already set?
Yeah.
And if it is, what does that mean for our choices, our actions? Do we really have free will? Or are we just like actors in a movie following a script?
Right.
Those are questions that philosophers have been debating forever. And this frame-based model, it adds a whole new dimension to the debate.
But even if the future is encoded in those frames, it doesn't necessarily mean our choices don't matter.
Right.
Maybe it's like those choose your own adventure books. The options are already there, but the path we take, it's still determined by the choices we make, even if those choices are, influenced by things we're not even aware of.
Exactly. The frame-based model, it doesn't say our choices are meaningless. It just suggests that the context, the environment we make those choices in, might be a lot more complex than we thought.
This whole discussion has been, well, it's been wild. A deep dive into the very nature of reality. We've explored these mind-bending ideas, tackled some really big questions, and we've seen how Zach's simulator has the potential to really unlock some of the fundamental secrets of the universe.
And it all started with this simple question. What if we've got time all wrong? This whole exploration has shown us that the universe might be a lot stranger, a lot more amazing than we ever imagined.
It really has, and a huge thank you to you for sending in these fascinating sources that sparked this whole journey. To everyone listening, keep exploring, keep asking those big questions, keep pushing the boundaries of what we think we know. There's a whole universe of mysteries out there just waiting to be discovered, and who knows what incredible insights are just around the corner, beyond what we currently understand. Until next time, stay curious.